So what I'm going to do is show you how to set up your computer so that you can start programming your Arduino. And what we're going to use is something by the Arduino company, and they're based out of Italy, but they're an international company at this point. They started 10 or 12 years ago with these small devices, and they became very popular. And all their resources are free, even though they do have an online store. You can buy additional things, which I don't use. The setup on theirs looks pretty, but it isn't quite as easy as the one we used to use, so I'm just going to step you through it. And the first thing you'll need to do is you'll need to set up an account. You'll notice that I'm using Google Chrome for my browser here, which I'd recommend that you use. And the website you can see is right here. You can just Google Arduino Create and you'll be able to click into this website. I'm going to click into the Getting Started menu first. And first thing I'll do is I'll get the Arduino editor plugin created, and this will actually download a program to your computer so that it'll be able to run and you'll be able to edit and create programs and then do things like that with it. It'll also set up the hardware interface to any Arduinos that you might plug in via your USB cable to your computer. So I'm going to just use their prompts, and you'll notice at this point I have a USB cable plugged into my computer ready to go, and I have my Arduino sitting right next to it, but I haven't plugged that in yet. So I'm going to go ahead and download the plugin like they recommend, and you'll see down below here it's saying it's going to be downloaded. And when this pops up, well, click on Open when done, and that will go through an install process for me, and I'll just agree to that. You will need an administrator account to go through this process. So I'm just accepting their prompts. So it's downloading the program. It should download some drivers as well. Will allow you to interface with your hardware, the Arduino that you're going to plug in. Your computer needs to have some information to communicate with it, and that's what that will be for. I'm going to allow access. Okay, I'll finish that. So it says my plugin is installed properly, and you see it says look for an icon down at the bottom of my screen, and you can see one right there. I'll just click on the next tool. Alright, it's starting up my Create, and then it asks me to log in. So I'll go ahead and sign up for a new account, and I'll use the same as my Skype account, Mr. Ryan. Pick a password that Kurosh doesn't know. And I'll try my email account at school. And you want to have an email account that you can monitor on your cell phone, because they're going to send you a message to authenticate your new account to make sure that you're not a robot like me. I'm not a robot. I'm lying right now. Okay, create account, and then they should send me a prompt. Alright, so they just sent me an email. I'm checking through it on my cell phone. I'm just going to click on the link, and my account is created. I'll go ahead and log in. Log in. Alright, so here's my account set up, and maybe I'll throw a photo in. Let's see if I can find a good photo here. Okay, so there's my account all set up. Now what I'm going to do is, and this is where things were a little bit confusing. I've already gone through this process once using another account name, so now I have a little bit of background with it. So I'm going to click back over to the main website, and you can either go ahead and type it in up here, or I can click on go to Arduino Create down on my toolbar down below. So here I am back on the home page for Arduino Create, and even though I was already signed in, you'll notice you have to sign in again for some crazy reason. So I'll go ahead and try to sign in under that new account I just created, and you'll notice it doesn't show me being logged in now. Okay, now you can see I'm logged in here. and I can check out my profile and so on and so forth. Alright, so the next thing we're going to do is let me show you how the web editor works. The Arduino Cloud is actually used for devices that are internet capable. So there are some different versions of the Arduino that can automatically connect to the internet through wireless. And so we're not going to use that because we don't have that type of Arduino. We have an Arduino Uno. So we're just going to go ahead and try out the editor here. And this is the area which we'll use to create programs, and they'll automatically keep those programs on your account for you online in the cloud. And so when you do something at home, it'll automatically be updated and you'll be able to see it at school when you come into school. The other advantage to this system, being internet based, is that if I wanted to share something with you as a starter point for a project, for example, or a classroom discussion, I can just give you guys a link to it and you guys can open it up in your Arduino web editor on any browser wherever you happen to be. The other thing you could do is you could share and collaborate with your peers, which you need to be careful about doing because there's a difference between collaborating and cheating. So let's make sure that we're being above board on that. So let me click into this, and they're going to go through a initial setup on this. So I'm going to go ahead and say agree. And once again, I'll just agree with all of their prompts. So this is the second plugin they need to have, and it's downloading the plugin. Okay, so here's our editor that just popped up, and this is what I was waiting for. And by the way, I can go back over here, and I think that brings us back to the main window you saw. And pretty much what we're going to be using is the Arduino web editor on here. But you can also see there's a help forum, there's different projects you can take a look at. Here's the store, you can go shop all to your heart's content. And like I said, we won't be using the cloud because our devices aren't cloud-based devices. We're using ones that are USB connected. So let's go back over to our editor. So let me set up a few preferences to make it easier for you to see my window, and you can adjust these as you would like as well. Maybe I'll create my font so it's a little bit bigger so you can see it a little bit easier on your screen. Maybe 20-point font. I can adjust the theme of this as a light or dark theme. I think I'll go with, well, you tell me. I'm not sure which is better, light or dark. You'll have to vote. I'm going to stick with a light theme for now. There's also some options to enable autosave, which I'd recommend doing. I'll just click on all these. Save when verifying and uploading. I'll show you what that means later. And advanced options. I think I'll leave those unchecked. All right. And right now it says I'm using 0%, 0 sketches of 100 use. So apparently on this site I get to put 100 of my own programs up here, which, to tell you the truth, isn't very much. And that's, you can probably go ahead and go onto their store and buy more access privileges. So that's where the scam is here. In any case, let's go over to my sketchbook. And once again, the Arduino, when they built it for an educational purpose, and so they're dumbing down some terms that we would normally use in computer science, assuming that the people who are using these little devices don't know anything at all. But I don't understand why they would not call a program a program. They call it a sketch instead. So unfortunately, they're using some non-standard language, and they're doing some things, other things that are non-standard that I'll explain to you, and I'll show you how we're going to pretend this is real C program, which it is, but they're just hiding certain things from you, which I don't like. So what we've got here is, this is a program, a format for a program ready to go, and you can just start typing in everything you need to go for it. But rather than start with a blank program, I'm going to have you start with a sample. So once the Arduino Create editor app is up and running properly, this will show up instead of a yellow bar that you saw across here with a message. And this should automatically recognize when you plug in through the USB. I'm plugging it in right now. You should get a message that your USB has just connected an Arduino, and it should recognize a type. For some reason this is not, but I think I have a bad Arduino here because I'm feeling it right now, and the microprocessor is very hot, which should not happen. So this is I just grabbed out of the box of Arduinos, and this must have been from some student who shall remain unnamed from last year. So I'm going to see if I can just go ahead and set it up manually. I don't think this is going to work though, but yours should end up working out properly. And make sure you have these at school with you. And so if you do have problems, I can just check out your boards one by one and make sure they're working properly on my computer at school. So I'm just going to pick up the Arduino Genuine Arduino. It's automatically telling me what it's recognized that it's on a specific communication port, number 3. I'm going to hit OK. And it gives me a little message here that says our program here is designed for an Arduino Uno, which is the boards that you have. Rather than writing a program from scratch, what I'm going to do is I'm going to go on to an example. The basic example I'll use is blinking a light. And when I click on this, it automatically loads up this program, and you'll see little marks here. I have a /* and a */. That blocks out this whole set of comments that somebody's typed in here as things that are not actually real code that the computer should ignore when it's downloading it to your Arduino. And so these are just comments they've written in to tell you what the program is being used for. So if I go full screen on this perhaps, so here's what it says. You can read the instructions what it does. It's just going to turn on and off a Arduino LED that you can control right on the board. And what I'll do is let me show you what that looks like and what a plugged-in board looks like here. So here's my Arduino, and I have it plugged in. You can see the USB is plugged in right here to the USB port. And what you can see, I have a green LED that's on right here. That's showing that the board is powered. There's also an amber LED right here that's actually connected to digital I/O pin number 13. And by declaring pin 13 as an output, digital output, I can make this pin go high and low. And when it goes high, this LED will light along with it. And when it goes low, this LED will turn off. There is another pair of LEDs right here which are important. They're the transmit and receive, and they're actually connected to the same transmit and receive pins you see right here. The USB cord is called a universal synchronous bus, and what it does, this is actually a universal serial bus. This actually sends data at high speeds back and forth to your computer, so you're transmitting and receiving. So this goes direct, makes a communication link right to your computer that you can use to program your Arduino. So looking back to our program on the screen here, the first part is just comments saying who designed it and so on and so forth. And this very long program, which is only 1, 2, 3, 4, 5 lines long. Apparently it took 3 people to write this program and to modify it, so don't know why. So I'll leave those names up there. I don't want to take credit away from their hard work of writing 5 lines of code. These guys are brilliant. But let me just go ahead and say, I'll add my name to the list here, modified. So I just added my name to the list of illustrious programmers that have modified this program. So as you can see, if I go over here now, let me just go ahead and save this. I'm going to save it on the Arduino cloud. And I'm going to call this, the original name of this program is blank. I'll just call it Rhine blank. And you must always label your programs with your name first, and so you know it's yours. And then put some sort of descriptive title after it. So I'm just going to call this Rhine blank. And this was the original blank sketch that you saw before. I'll leave that in there. And this is Rhine blank. All right. And so what I'm going to do now is show you what's in here. So up above were just some comments describing what the program does and who wrote it and when. And you need to have something like that in all of your programs. Then what we see here, there's 2 parts to any program. If I go to the blank program over here, there's the setup portion of the program and there's the loop portion of the program. This is not what standard C programs look like in reality, and I'll explain the difference later. But basically, we talked before when we were setting up flow charting that we had some housekeeping to do, and typically what they expect you to do is put your housekeeping activities in the setup area. So we're setting up the hardware and software to run the way we'd like. And then typically for the Arduino, they like you to put your program down here that just loops over and over again. And initially we'll use the looping feature down here, but very quickly we'll start putting everything in the setup program and try to treat this like a real programming system instead of this little kiddie one. So let's go over and see what they have down here. And remember what I said, one of the things you had to do was set up your input-output pins as to what you're going to use. And this is actually, the pin mode function does that, as you can see here. Anything in orange is a function, and you'll see parentheses that define any function. A semicolon is at the end of every line of code that you have. There's a couple of examples where you got to understand what a line of code means, but generally speaking, you'll see a semicolon indicating a line of one code on line 29 here. Up here, these gray lines, just as we saw above, are also comments. We're using a block comment above, using a slash star, then a star slash to start and stop this whole block of comments. But for a single line of comments, we put a slash slash, and it'll cause that to be a comment. So in this setup, what it tells you it's doing is taking one of your digital pins, and it says the digital pin is called LED built-in. Well, I already told you that's pin 13. And I'll put that note down here. That's pin 13. Okay? Is an output. Remember, these 14 pins on our board, on one side of our board, are digital inputs or outputs. You get to specify which they will be. Now, they're actually using this predefined word. The word LED underscore built-in to our compiler is recognized as the number 13. So, and it makes this more readable in English. And this is the type of thing we'd like to see in our program, something that's more readable rather than some crazy numbers we have no association with. But I'm just going to show you that we could just put the pin number on here, pin 13. I'll put it in all three places. So this tells me I'm going to designate which pin number I would like, and do I want it to be an input or an output? Well, this is an LED, and we're pushing out a value to an LED, so I'm going to designate that as an output. So that is all of the setup work I have to do, all the housekeeping work I have to do for this tiny, tiny little program. So what we want to do over and over again, that's why we'll put it in the loop area, is we want to turn the output pin high and low, on and off, over and over and over again. So to turn an output pin on or off, you use digital write. That's the name of this function. Open parenthesis, you put the pin number. Now remember, before they had actually a word defined as pin 13, which was LED built in. And then you tell it with a comma, you tell it you want it to be high or low. And close parenthesis, semicolon ends that line of code. So that's one line of code that your computer will execute. It'll turn the LED on. This next line is a delay, a bad delay. We'll use delays for the first couple small programs until we figure out how to use an internal clock. But delays are bad because they shut down your microprocessor, so you can't see anything that's being done and you can't do anything while you're waiting. So we're delaying for 1,000 milliseconds. All right, so that's why it says over here, wait for 1 second. And after 1 second has passed, you'll go back over to that pin 13 and digitally write to it a low value, a 0 voltage value. And that'll turn your LED off. And then you'll delay for another second. And then you come to the end of this. So at the end of the loop, what I have here is a closed brace. And if I click on this closed brace right here, you'll notice up above, you'll see that was highlighted with a square. And that shows you when I get to the end of this delay, I'm going to bump right back up to the beginning of that loop right here. And I'm going to execute these lines of code over again. And so it's going to go over and over and over again in this loop. So that's the simple program. So I just made a few changes, so I'll go ahead and actually I have autosave on, so I'll let the saving take care of itself at this point. So what you need to do is once you write your first little program, you'll need to, in the real world, what we call compile the program, which means it will go through it and it will translate this into the ones and zeros the computer's going to expect it to be downloaded. But first what it does, it deletes all these comments, which are for the human reader, gets rid of those because computers don't care about these words in English. And then it'll convert all these lines of code you see here into the ones and zeros that it's expecting. Before it does that, though, it just checks to make sure everything is done properly. If you're missing a semicolon, if you spell something wrong, if you're using something it doesn't recognize, it will give you an error. And those are called compiler errors, and we'll talk about those more later. But since we haven't made any changes that should hurt us, if you watch, I'm going to go ahead and compile. You will not hear me use the word verify that they use. This is called compiling. And if you watch, it's busy, busy, busy. It's compiling, compiling, compiling. And if you watch down below, success, saved on the Arduino cloud and done verifying. And if you'll notice, it gives you some messages down here, and it tells you what the compiler is. And you notice here, it's using the word compile here, folks, not verify. And this is using 2% of my program storage space on my Arduino. My Arduino can hold 32,000 bytes of information. I'm only using this with this tiny little program, only 928 bytes, so on and so forth. All right. And so those are my messages. Now, if I had something that went wrong up here, it would tell me line by line what was wrong, and so I can hopefully correct it. So I'm done compiling and saving. So the next thing I would do is I would actually download it over to my Arduino. Of course, they use the word upload because they're looking at this from the perspective of the Arduino. I'm looking at it from the perspective of my computer. I'm going to download it to my Arduino. So like I said, my Arduino that I have right here is overheated and not working, so this thing is a bad Arduino. But when you do this, you should have this set to your Arduino, and it should show it on here as being active. And when you click on this, it will give you some messages, busy, busy, busy. I'm not sure why it's showing verifying. It's supposed to be down. Oh, here now it's saying uploading. And when it says uploading, if you look on your Arduino board, you'll see the transmit and receive LEDs blink on and off. Unfortunately, you're going to see in a moment here, this will come up with an error. On your Arduino, though, if this works properly, as soon as the program is done downloading, it'll actually run the program. And so if this works properly for you, unlike me, it will actually cause your pin 13 LED, the built-in LED that's in a orange, yellow, amber color, it will blink on and off, 1 second on, 1 second off, 1 second on, 1 second off. And it'll do that forever as long as you have power applied to the Arduino. And that's the end of your first program.